Okay, we're going to continue with our fundamentals. Today we're going to talk about algebraic expressions. A variable is a letter that can represent any number from any given set of numbers. So we use variables, letters, in math so that we don't have to write the same expression over and over and over and over again. We come up with algebraic expressions so that x or y or z can be a placeholder for any set of numbers that would make this expression make sense. If we have an expression with one variable, we call that a monomial. It's an expression of the form a, which is a real number, times x to the k power, another real number, and we can model a lot of mathematic relationships with algebraic expressions. We can't model a whole lot of them in one variable. That's why we introduce more and more variables. And so a binomial is two monomials, and a trinomial is three monomials, sometimes in the same variable, sometimes in another variable. If we have more than three terms in our expression, it's called a polynomial. And a polynomial can have as many terms as need be. And the further we go up in mathematics, the more we're working with polynomials as opposed to algebraic expressions with two terms or three terms like binomials and trinomials. So the degree of the polynomial is the highest power of the variable that appears in the polynomial. We see here that the highest power that appears is a 2. So this is a trinomial because there are three terms that has a degree of 2. Here is a binomial that has a degree of 8. So those are mathematics terms that we need to be able to intelligently talk about in terms of our expressions or our equations that we're working with. So on our polynomials, we can add them, we can subtract them. We add and subtract like terms. Like terms means the variable must have the same power attached to it, and then we can add or subtract the coefficients. Here we have 5, here we have 3, the coefficients in front of those like terms. So like terms are something that I'm sure you remember from your lower mathematics work. We have to be careful when we're subtracting polynomials. We still need to make sure that we have like terms, but we need to be very careful with that minus sign. So we'll watch that very carefully. We can also multiply and divide algebraic expressions. When we multiply algebraic expressions, we have more processes that we have to learn. For instance, if I was going to multiply two binomials, here I have a plus b times c plus d. If I was going to multiply those, then there's a process by which I want to go through and make sure that I don't miss any of those multiplications that need to happen over those plus signs. Many of us learned it as FOIL. You might have learned it as something else. You multiply the first two terms, that's f, so first, outside, inside, and last, the last two terms, that's first, outside, inside, last, and then you gather like terms if you have any terms that are the same. For instance, if we were going to find the product of this binomial and this trinomial, then we would take the first term and multiply it by every term in the trinomial. Then we would copy down that mathematic operation. That's important. You can't miss that. Copy the mathematic operation and then take the other term and multiply it by every term in the trinomial. We distribute everything out. We do all the mathematics that's here. We're going to distribute this 2x over each one of these terms, come up with the expansion of that, and then we're going to gather like terms, and then we are going to simplify. And so that's something we've done over and over and over, not new information for us. We'll get some practice on that when we do homework. Now there are some special products that you've seen. We have the product of two factors. We usually call these factors. They are algebraic expressions where we have the same lead term in both factors and we have the same tail term or last term in both factors, but we have the opposite operation. And so that's known as the difference of two squares. And we know all of these. There's the the repeated sum of squares, there's the repeated difference of squares, and then we do the same thing with cubes. So we can do this by hand. We can write a plus b times a plus b times a plus b, and we can do that by hand, or we can memorize this formula. I'm not really big on memorizing formulas. I'm big on doing mathematics operations. So you can do that either way that you've been taught. If you happen to memorize these, that's fine. Now going in this direction is a little bit easier than factoring and going back in the other direction, but we'll get some practice on that too. So if we are going to factor an algebraic expression, we want to break it down into the factors, factor means multiply, into the product of how many ever factors were in there. We want to simplify and get all those factors as much as we can. If we're going in the opposite direction, then we are expanding factors to get our algebraic expression. Again, just more math terminology. So if we're factoring trinomials, then we know that we need to have two parentheses. We need to look at the coefficient on our x squared term. If the coefficient is 1, and in this case it is, then we're just going to have our parentheses, and we're going to put an x, and then we're going to put another x in the second parentheses, and then we've got to figure out what is it that we multiply together to get 12, positive 12, and add together to get positive 7. And those are going to be the two numbers here that are going to be the last terms in our factorization. So when we add together two numbers and get 7, that's 1 and 7 or 3 and 4. So if we multiply those same numbers together, we get a product of 7 or we get a product of 12. So we know we're looking for 3 and we know we're looking for 4. The fact that this has nothing but positives in between each term definitely helped that process. So remember, this is, again, just a review. There are special factoring formulas. If you'll remember, these are just those expansion formulas backwards. So we've already looked at this side and it's given us this as the result. Now we're just doing it in the opposite direction. So these are probably already in your notes, but you've just written them in the other direction. Difference of squares, perfect square, difference of cubes, and sum of cubes. The last technique for factoring is factoring by grouping, and we're just going to look at one example. The first clue that you're going to have that you might be able to factor something by grouping is that you're going to have 4 terms. If you don't have 4 terms, you're going to have, or at least 4 terms, I should say, you're going to have a hard time factoring by grouping. So if you have 4 terms and you're asked to factor something, then look for a set of 2 terms that have something in common. Here we can see that x cubed and x squared have an x squared in common. Here we can see 4x and 4 have a 4 in common. We can also see x squared and 4x have an x in common, and so forth. So you can factor out, put parentheses around what you think, because addition, you can reorder the terms, it won't hurt anything. So you can group together what you think and factor out what they have in common, and hopefully what you have left is what we call a repeated factor. And if that's a repeated factor, then what we're going to do is factor that out over this plus sign, and so we're going to factor out x plus 1, and what we're left with is x squared plus 4. So factoring by grouping is not terribly difficult. It's not something we do a lot, but we will practice that a little bit. So I know that was a really quick video. Make sure you have everything in your notes, and we'll work on the homework and continue our review.